This lesson, 5.6, Simplifying Our Square Roots, Day 3. For these examples, we're going to be multiplying and then simplifying the square root. If you look at the first one, letter A, I have the square root of 2 times the square root of 10. Because both of these numbers are under the radical, I am allowed to multiply them. So when I do 2 times 10, I would get 20. At this point, you then want to look at your list of perfect squares. 20 can be broken down. So start breaking it down. 20 would fall between 16 and 25, so you would start with 16. 20 divided by 16 is not going to go in evenly. 20 divided by 9 is not going to go in evenly. But 20 divided by 4 will go in evenly 5 times. Then you'll come over under your 20 and write your two radicals, your square root of 4 and the square root of 5. The square root of 4 is the perfect square. You want to simplify that down to a 2, and the square root of 5 stays in the radical because it is not on our list. 2 square roots of 5 is your answer. We're going to do the same thing for letter B. When I look at letter B, I have a 7 and a 35. Neither of those are perfect squares, but they both are underneath the radical. So I can take my calculator and multiply 7 times 35, which is going to give me 245. 245 would be at the very top of our list. So you have to go through and you will divide down until you find a number that works. As you go down your list, you should find that 49 is the perfect square that divides into the 245. 49 goes in 5 times. So we will have the square root of 49 and the square root of 5. The square root of 49 would change to a 7, and the square root of 5 stays. Number C, letter C, we have the square root of 3 times the square root of 15. So again, they're both under the radical, so you can multiply. 3 times 15 is 45. We have 45 divided by 36. That's not going to work. 25 is not going to work. 16 is not going to work. But when you get to 9, you know that that'll go in 5 times. So we will write our two radicals, the square root of 9 and the square root of 5. The square root of 9 is our perfect square. It comes out of our radical and changes to a 3. And we leave the square root of 5 next to it. Going down to letter D, 5 times 12 is going to be 60. So we're going to break down 60. If you go through your list, you should figure out that the biggest perfect square is going to be 4 that goes into 60. So 60 divided by 4 is 15. And we will have the square root of 4 and the square root of 15. From there, the square root of 4 changes to a 2, and the square root of 15 stays. The last one like this is the square root of 6 and the square root of 8. What I would do here in this problem, just multiply them together. Yes, the square root of 8 can be simplified down, but it's easier if you combine them first. So I have 48 under my radical. So you want to start with 36 and start dividing. So 48 and divided by 36 will not work. 25 will not work, but 16 is going to be the magic number that works. So 48 divided by 16 leaves you with 3. So make your two radicals, square root of 16 and the square root of 3. The square root of 16 is your perfect square, and it turns into a 4. And you're left with the square root of 16 under the radical. These last 5 problems we have are with division. So we talked about a few sections ago the quotient property. The quotient property for radicals says that I can take a fraction that is under a radical and split it into 2 radicals. So the square root of 5 over 9, I can split into the square root of 5 over the square root of 9. So looking at these, the square root of 5, that is not on our list, and we can't simplify it any further because there are not any perfect squares that go into 5. So we're going to leave it the square root of 5 on the top of our fraction. However, the square root of 9 can be simplified. That is a perfect square, and the square root of 9 is 3. So for these problems, you will leave them as a fraction. Square root of 5 over 3 is your final answer. When you go over to G, we're going to do the same thing. We're going to break it up into 2 radicals. Square root of 11 over the square root of 144. The square root of 11. 11 is not a perfect square, and there's nothing that can go into it. So we leave it the square root of 11. But the square root of 144, you should notice, is a perfect square. So you will change that to a 12. Square root 11 over 12 is your final answer. If you look at H, you should notice that 49 and 81 are both perfect squares. So when you go to split this into your 2 radicals, they both are going to simplify. I have the square root of 49 over the square root of 81. 49 is going to turn to a 7, and the 81 would turn to a 9. So 7/9 is your final answer. Same thing's going to happen with I. You should notice that 64 and 25 are on your list. They are perfect squares. So I'll have the square root of 64 over the square root of 25. The square root of 64 is 8, and the square root of 25 is 5. So 8/5 would be your answer. And finally, letter J, 7 and 100. So the 7 is not a perfect square, but 100 is. So when you split your 2 radicals, the square root of 7 would stay on the top, but the square root of 100 turns to a 10. So your final answer is square root of 7 over 10.